Did your display for your laser arrive looking like this, where the batteries are totally flat? Well, this is what I did. And here we are. Very simple. Bits out the junk bin. Regulator. May not need that, so may not fit that in the real world. And 2 surface mount diode packs and a surface mount transistor and an 820 ohm resistor. Now that's going to come down here. The current, we'll ignore the base current. If we make the current down here enough, then the base current through here is going to be so little that it won't affect it. You know, we're talking microamps here, and we put milliamps down here. And here's the battery. Now the little temperature probe on the laser had a 2 button cells. Was it 44 button cells? 2 of them in parallel. And when it arrived, there was nothing to stop them from powering the unit, and of course they were both flat. So I thought, I'll just get some batteries. Popped out. They're a silly price. And I decided, well, I'm only going to use the temperature display when the laser's turned on, so I might as well just power it from the 5 volts. So we knocked up this little 5 volt regulator, and up here in the corner you'd have been seeing me build it on a bit of vero board. So here we go. 5 minus 0.6 equals 3.2. Divide that by 820 and we get 3.9 milliamps, nearly 4 milliamps. What more do you want? So we're going to have 4 milliamps going down here, minus a little bit that's going to go into the base. Now there's going to be 0.6 of a volt to 0.7 of a volt across there. So if we say they're 0.7s, and we'll say they're 0.7s. If we say it's 0.6, we'll say they're 0.6. They're all diodes. So they're going to be close to each other. So basically that takes that diode out of the equation, because that point there, the transistor is going to try and keep 0.6 across there. So 0.6 across there. It means the voltage at that point is going to be whatever these two are. So about 1.2 to 1.4. And it will regulate it at that. Little 10 mic capacitor, and soldered directly to the battery terminals, stuck on a little board, and then the wires connected to the 5 volts of the laser. So whenever the laser's turned on, the 5 volts is there, it will display the temperature. Now I hope that's enough of a description, and you'll see it working in a minute. Well, somehow I lost the audio but gained main sum, which you can hear in the background. So that's got to be investigated. I never used to have main sum, but OBS has changed, and I never used to have a mic input selected for OBS to use the mic, and now I do, and now I've got main sum. So I don't know what's going on. But here's a little board, and you can see me bodging it onto the power leads. The power leads are just soldered to the battery inside the temperature sensor. And I'm just being crude and sticking them on very crudely, as you can see. You know, don't want to burn my fingers, but it's best to use your fingers. If you use tweezers when pushing down on soldering the end of the wires, if it's PVC, you can quite often push the tweezer through the insulation and cause a short. Oh, that's a bad joint, isn't it? I'll have to come back to that later. But here we go, putting the earth on somewhere. Ouch, must have burnt a finger. Oh no, a bit of solder. Can't beat tin your wires. Now you can see that smoke off the tip. That's all the flux burning off my iron. So this isn't the best way of putting wires onto boards, because all the nice flux you had is now in the ether, burnt away. But who cares? Doesn't really matter, does it? So there it is. What am I going to do now? Oh, why don't you get around a bit? Put 5 volts on. Oh look, there it goes. Alright, it's upside down. Hang on. Oh no, am I going to turn it around? Yep, I'm going to turn it around and put it out. Oh no. What am I doing? You know, where's the professionalism on this one? There you go, 21.1 degrees C. Bit out of focus, but yeah, it's working. What more do you want? I've decided that the board's a bit too big, so out will come the trusty side cutters, as you do, and I'll chomp them away down the board. The easiest way of cutting vero board, chomp it with side cutters. There you go. Well, that's a design that Bodgett and Scarpa would be proud of. Alright, a bit of double-sided sticky to stick the board to the back of the display. As you can see, I've chomped a little hole for the cable to come through. The double-sided sticky is very sticky, but it can be a bit troublesome to get its backing off, but it's about half a millimetre thick, so it's very good for sticking things on, as it takes up, you know, some components can sink into it, and it sticks boards down really well. But I say it's quite old, and I'm just using it up. There you go, stick it on there. So it's looking good now. It will fit in the box. It's not got, the board's not going to fall off, and so I think the job's quite good. There we go. Put the power back on, and be ready to put back inside the laser, and perhaps I don't run some cables down. And as we can see here, there's the board. So there's the sensor mounted. Oh, sorry, there's the display mounted on the back, and the cables come down and end up just going into the laser terminals for ground and 5 volts. The black cable goes out through a hole and is just connected back to the return pipe for the water. And so, happy chappy. Well, I thought I'd better show you a picture of the 1.4 volts on the display and the 5 volts that's driving it, and a nice picture of the display being powered, and the job's a good one. Well, I'm going to drop a comment at this point that my display did glitch after this. I don't know if it did it when it was originally running off batteries, because I never had it running off batteries, but it did glitch, and it turned out to be the sensor running into the laser compartment. I moved the sensor so that it fed out of the box underneath the cabinet and then connected to the return pipe, and it was rock solid after that. I thought it might have been a voltage glitch, but it wasn't. It was a spike from the laser firing. Well, if you want to see more awful videos like this, hit the subscribe button, click on the bell, and hopefully I'll see you on the next one.